All right, so in the previous videos that we've made, we've explained the background for geometric and arithmetic sequences and where the formulas that we're going to use to generate their explicit definition come from, or why the structure for those formulas is the way the structure is, okay? And in that process, we worked through an example where we found little baby formulas, I guess, for finding the value of R, figuring out what the pattern is, or finding the value of the first term or the 0th term or what have you. So the previous videos explain all that background, but that discussion is kind of lengthy and there's a lot of stuff flying around. And so I thought it would be good just to have a video that's just clean and simple, doing an example. Just here's how we're going to use the formula. So that's the purpose of this video. If you're not ready for an example of this, you might want to go back and watch some of those other videos. But if you are ready, or if you just don't care about the background and you just want to get to brass tacks, then this is the video for you. All right, so with that said, let's go ahead and get started. You can see here, I haven't even bothered to write down a learning objective or anything. The learning objective is to be able to use these formulas to find the explicit definition or the explicit formula of a geometric sequence, okay? So in the previous video, we mentioned that all of our answers are going to have this structure. And in this structure, remember, the only thing that you're actually needing to find is the first term and the value of R, which represents your pattern, okay? And your answer is going to leave a sub n and n in the formula because those those are the variables that enable me to find all the terms, right? So I need to be able to find any term and I need to be able to find that term's value. So these two things change for a given sequence, a sub 1 and R. Those are the constants you need to find. And we said you're going to find R first, and I gave you a formula. Now, in the previous video, I wrote this using a radical, and I wrote this using an exponent. You can write it either way. I think because of the fact we're going to type this into a calculator, probably most students prefer it with an exponent format, and so that's the way I chose to write it here. And then we've got this formula to find the first term. After we know R, then we can use R to find the first term. And that's the formula we have here. Now, just in case you haven't watched the previous video and you're skipping right to the example, make sure you understand how these things work. So when I say a sub n and a sub k, those are the values of two terms they've given you. So say they gave me the third term and the fourth term, then m and k are 3 and 4. But the values of those two terms, that's what I'm plugging into this fraction right here. And over here, you can use any term you want. So it doesn't necessarily have to be the same term that you put up here in the fraction, although many students choose to do it that way. Any term that you want, once you know what R is, you can plug that term into this equation to find the first term, okay? So these are the formulas that we're going to use. Now, if you don't already have this captured in a succinct version in your notes, then you may want to pause the video right now and write this down. You also may want to pause the video to write down the example that we're going to do. Okay, but once you've got everything recorded in your notes, then let's roll through this. All right, so the first thing that I like to do, again, I've said this before, is I like to start by writing down what my answer will look like. And we know that with a geometric formula, our answers will always look like, and it says that it's geometric, right? Geometric sequence. Our answers will always look like this. That's what our answer is going to look like, okay? The first thing I want to do is I want to find the value of R. That's the first thing I want to do. And in the last video or on the previous piece of paper, I gave you a formula for that. That R is going to be equal to the ratio of two terms raised to the power of 1 over the difference between the two terms. Okay, so here they've given me two terms. It doesn't matter which one I call K or M, it doesn't matter. And for that matter, it doesn't even have to be K and M. I think in the original video, I used M and P. Okay, so if those are throwing you off, it doesn't matter because it can be any term, literally any term. So these are the two terms that I have. Most students like to make the bigger term be the one in the top, but that doesn't matter. You can do it either way. But because that's what most students like to do, I'm going to do the same thing. I'm going to make a sub 13 be my a sub m. And I'm going to make my a sub 8 be my a sub k. Okay, that's what I'm going to choose to do. But it really doesn't matter. You can do it either way. It's going to work out fine. So what this means is that a sub m, that's the value of the term. So this is the value right here. That's what's going to go in the top of my fraction. So, and remember, we talked about with geometric sequences, sometimes you just got to work with big numbers. That's just the way things go. Sometimes you just got to deal with that. Okay, now in the bottom of my fraction is the value of the other term. So a sub k is equal to this thing. So that's the value in the other term. Now I want to pause right here for just a second and make a side note. If you are working with a geometric sequence and you see that some of the terms are positive and some of the terms are negative, as much as is possible, you want to make sure that you use one positive and one negative here. Okay. Now, in this case, I don't have a choice because they only gave me two terms. If they gave me 3 terms or 4 terms or 5 terms, it's important that I have a positive and a negative here, because if you don't, you'll miss the fact that R is going to be a negative number. Okay. So if the signs are changing, you want to make sure the signs are different here, because that's going to tell you that R is negative. Okay, now with that little side note, now I'm ready to make the fraction in my exponent. So it's going to be 1 divided by, and because my terms are the 13th term and the 8th term, it's going to be 13 minus 8. 13 minus 8. Okay, again, you can have it in the other order, but it has to be consistent. If the big number is in the top of my fraction, then that number goes in the front of my minus sign. Okay. The number that's in the bottom of my fraction, that term number goes after my minus sign. And that's how I need to match it up. And then from here, I just type it into my calculator, or maybe I just know the answer, whatever. In this case, I'm definitely typing in my calculator. But I need to simplify my fraction first. So 13 minus 8, that one I do know. 13 minus 8 is equal to 5. So in the fraction in my exponents, I'm having a 1 over 5. And now this I'm going to type into my calculator because I definitely don't know what that one is. So on my calculator, with a little help of my calculator, I've got this 995,328 divided by a negative 128. And so I get this, a negative 7,776. And now that I'm going to raise to the 5th power, 1/5 power. And that gives me R is equal to -6. R is equal to -6. So now I know what R is. R is equal to -6. Okay. Whoops, you can't see that I wrote that. There we go. So now I know that R is equal to -6. I've got that. Now that I've got R, I'm going to move on. Sorry, I hope I'm not making you seasick there. I'm going to move on to find a sub 1. So once we know R, then we can find a sub 1. And for a sub 1, we had a formula for that too. We said that you can find a sub 1 by taking any term that you know and dividing it by R raised to the power of that term's -1. Okay, so again, it doesn't have to be the same one that you put in the top of the fraction. Even though I'm using the same symbol, it doesn't have to be the same one. You have lots of flexibility here. Me personally, I tend to choose the ones where the numbers are smaller and look easier. So personally, I would pick this one. But it doesn't matter. You can pick this one, and that's fine. You're just going to get bigger numbers. I'm going to choose this one, though. So I've got my terms value is -128. So my a sub m, that's a -128. And I'm going to divide that by R, which we just figured out that R was equal to -6, raised to the m-1 power. So here I'm working with a sub 8. So my exponent is going to be 8 minus 1. 8 minus 1. And this will give me the value of my first term. So again, I'm just going to type this into my calculator. Obviously, 8 minus 1, that's equal to 7. So what I'm going to type into my calculator is -6. And remember, when you're dealing with exponents, that those parentheses are important. -6 raised to the 7th power gives me this big old number right here. So a sub 1, -128 divided by this great big number. Okay. And then I can figure out that final answer, -128 divided by that great big number, 279936. Okay, now I get this funky decimal. Remember, one of the things that I mentioned is when we're working with these problems, it's almost always easiest if you write your answer as a fraction. So if I just push math and convert that answer to a fraction, there we go. A sub 1 is 1/2187. And I don't know about you, but I'd rather write this fraction than this big funky decimal where I have to move things or use scientific notation or whatever. I think that's a lot easier to work with. All right, so now we know what a sub 1 is. A sub 1 is this thing. So we know R, we know a sub 1. Now I'm ready to write my answer. And since I kind of have bumped in the bottom of my page, I'm just going to write my answer right over here. So what did we find the answer was? Well, I'm going to have an a sub n equals a1, we figured out was this fraction right here, times r, and we figured out r was -6 raised to the n minus 1 power. And there's my answer. All right, so hopefully that helps you with how to use the formulas for geometric sequence. Thanks for watching. Have a good one.